All right, welcome back to Computer Science E76. So sadly, the semester is almost over, even if it feels like you're just now getting the hang of Evil Hangman. We have a few topics on the agenda today, but first, some teasers for some things that are still on the horizon. So next week will be our last lecture. It will be a shorter lecture than usual. Our own Dan Armendariz will return for a guest appearance. We will wrap up the course, introduce some directions in which you can go, either for your remaining projects or after the course, and then just generally offer some one-on-one Q&A for the student choice projects, which will be in progress by then. You should have heard from your teaching fellow already about that, but if not, just ping him or drop help@cs76.net a note to inquire. So we thought we'd do this. We actually crammed into the beginning of the semester a little more HTML5 than we had intended to, and it felt a little weird to come back to HTML5 when really you're knee-deep in Objective-C now. So what we thought we'd propose is that for the last project, rather than making it an official requirement, we'll simply make it extra credit as an opportunity to perhaps redress some previous project that you perhaps weren't so pleased with. What do we mean by extra credit? So we're not going to ascribe a very specific point value or weighting to this, but rather to say, like many courses, if at the end of the semester, when we look at the distribution of your scores and hopefully upward progression, perhaps with a little blip there earlier on, we will take into account the fact that you have done this last HTML5-based project, the design for which is entirely up to you. And the idea is that you would then be bumped up from wherever you are if you are, in fact, borderline. So can't hurt to do it. In fact, it would be fun, perhaps. You only have about a week and a half, though, which is a little less, so we thought it would be only fair not to expect it as a strict requirement. So any questions on that, just let us know. But you'll see in the remaining specification for student's choice, which will go up shortly, exactly what you need to get from your TF in the way of an OK before proceeding down those lines. And lastly, so the culmination of this course in a few weeks' time is meant to be the sexy named app party, the idea of which is to gather as many of us local folks and even some of our distance students who up until now have been quite remote in Cambridge for the evening. It'll be 5:30 to 7:30 on Friday, 5/13. And the idea really is to bring your Android phone, bring your iPhone, bring your Mac laptop, bring your family and your friends, and really just mingle. We'll have some cake and some food and some drinks, and the idea is that you will have your apps, particularly the student choice apps, either 2 or 3 of them, so that you can just delight in what everyone has done. And hopefully it'll be a fun way and low-key way to end the semester. Any questions about things administrative? No? All right. So last week we looked at data-related things, how you might store data, how you might read data. We looked at property lists. We looked at which in turn are XML files. We looked at SQLite. SQLite in Objective-C in the iOS SDK, recall, is a C-based API, and it's not the most fun suite of functions to actually call. Certainly is not as easy to engage with as a language like PHP or Python, which are really better designed with those kinds of queries in mind. But it turns out that there is a layer that Apple's offered for some time now called core data that can actually sit on top of SQLite, or in fact on top of other things like XML files or blob files. And this is called core data. Core data is an abstraction over what is ultimately an underlying storage mechanism, something specific like SQLite, but it allows you to model your model in the MVC paradigm, so that if you have a student object or an employer object or employees object, and you have one-to-one relationships, one-to-many relationships, many-to-one relationships, you can model these not only in Xcode visually using a sort of interface builder-like GUI tool to actually say what your entities are, what relationships they have. You can then interface with those entities in your own code without having to worry about a select statement, a delete statement, an insert statement. You don't have to know any SQL whatsoever. So for better or for worse, it allows you to abstract away what might be some underlying minutia or frustrations when it comes to coding in terms of your queries at that low level. So what I thought I'd do here is we could spend a whole deal amount of time on this, but what we thought we'd do, particularly with the student choice projects on the horizon, is give you a sense of what you can do here and then allow you to decide for yourselves if this is a route you want to go in terms of integrating it into your projects, or if you prefer to use SQLite or just property lists, or if just not applicable, no such data layer whatsoever. So I'm going to go over to Xcode here. And for the first time in lecture, at least, I'm going to go ahead and create a new project. This one, I'll keep it very simple for now so that we don't get distracted by other aspects of the templates. I'll choose a window-based application, hit enter, and for the very first time, I'm going to check that checkbox that we've been waving our hands at for some time that says use core data. Like all of these templating things, this really just helps you by pre-populating your project with the framework that you need, the linker flags and so forth that you'll want to add in. It provides you with some template code and some sample code and comments, but you could do this from scratch if you so chose. But we're going to keep it simple like this. I'm going to call my project core data. I'm going to keep the company identifier edu.harvard. As an aside, those of you who have opted in via the course's homepage to giving us your Apple ID email address and your device ID, you should have already gotten an invitation from us to join the course's university program team so that you can actually install your own code onto your own hardware. If this sounds unfamiliar, just check out the course's homepage. It's a number of steps, one of which relates to this company identifier, which just allows you to restrict with these programs exactly who or what devices can run code. So we're going to keep it pretty generic, edu.harvard, so any of you with your own certificates can use it. I'm going to go ahead and save this on my desktop as core data. And now I have an empty project file here. Well, let's see what we've got on the left-hand side. I'm going to maximize my window. I'm going to expand these groups over here. And what, if anything, jumps out at you as different vis-a-vis the templates we've started with in the past? Yeah, so we've got core data.xc data model D, and then down here too, we have another framework. And recall we had to jump through some hoops last week to add SQLite to the framework folder there, but this time it's been provided for us. So let's focus on this GUI aspect first. So I'm going to click the file called core data.xc data modeled, and it's going to open a little WYSIWYG editor like this. Most of this is blank space, so let's zoom in on the important stuff. And you'll see perhaps some familiar terms, at least if you've taken a database course or have been playing in the SQL world for some time. There's this notion of entities up there. There's attributes up here, relationships here, fetch properties down here. And so this tool, and we could do this with some other mechanism, but this tool is going to allow us in a fairly user-friendly way to say, I want to define a student object, which we did several weeks ago, but I don't want to have to worry, at least for now, about implementing the class definition and the properties and the underlying instance variables. Really, I want to keep things higher level and just think of a student as a real-world entity that has attributes associated with him or her, like an ID number or name or a major, anything along those lines. And I just want to express myself by defining this with this little tool. So I didn't print out in advance today's code, but if you're on your laptop, it is available on the course's website. And what I want to go ahead and do is define two attributes. Let's keep it simple. And let me try to stay consistent with the printout so that you can follow along at home correctly. Let's go ahead and define, let's say, a student. So where to do this? A couple of ways to do it. I'm going to go at the bottom of the screen and choose Add Entity. And you'll see that what appears at the top left is an empty entity, named by default entity. Let's go ahead and call that student and hit Enter. Now on the right-hand side, I can begin to say what defines a student. What relationships does a student have? Well, let's pick a somewhat arbitrary example. And let's say that the goal at hand is to model students, like we did weeks ago. And then so that we have a relationship opportunity, let's say that students take courses. And conversely, courses have students. So now we can model, say with arrows on a blackboard, exactly what the relationship here is. So in terms of the student, let's go ahead and give him or her a name. So I'm going to say that one attribute, or in a relational database, one field or column is going to be called name. There's a few data types that core data provides. Notice they're not as rich, perhaps, as you get in SQL proper, but they are fairly diverse. We have integers at the top and other numeric fields, but we're just going to go with string for now. And there are NS type objects that map to each of these. So let's say string for this. And let's say that every student here at Harvard has what they call a concentration or major. And I'm going to keep it simple and similarly make this here a string. All right, I'm going to save it now. All right, so now let's define a course. I need another entity called course. So let me scroll down here, click Add Entity, and now up at the top I can define a course. And now, frankly, these are the silly little things that you'll trip over once in a while with Xcode 4. I'm clearly highlighting course, but I see students attributes on the right. So generally futzing around, clicking here or there, quitting the program and loading it back up will yield the correct view, which should look like that. So here we are. I've just clicked away and then back onto course. Let's give a course an attribute. How about a course has a title? So let's go ahead and say a course has a title. That's going to be a string. And let's leave a course simple. You can imagine having days and times and other such details, but let's keep it simple. So now the relationship. So if this hand is a student and this hand is a course, in which direction might we reasonably want to draw arrows to represent some kind of relationship between student and course?
Student to course.
OK, so student to course, because you can imagine, such as ourselves here, you take one course, maybe multiple courses per semester. So you might associate some kind of set or array or some collection object with a student that contains the set of all courses he or she is taking. So let's go do that. Let's go over to student here. And then let's go over to relationship. And let's go ahead and define the courses that a student takes as having a property name, if you will, of courses. Hit enter, but now I need to specify a destination. In other words, what is the endpoint of this arrow, this conceptual arrow that we're drawing? Well, the relationship is from student to course, so the arrow should be pointing at course. And so now we've told core data that we now want to have a one-to-one relationship between student and course and a course. Now, this isn't ideal because, right, a typical student will take 1, 2, 4, 5 courses per semester. So it'd be nice if that were one to many. So when in doubt with Xcode 4, you can often dive in deeper by changing the view currently displayed to you. So if you look at top right, we've used this quite a bit for Interface Builder. But if I click this, I get a whole panel of options. And now with student selected, let me go over here to Let me go over here to the data model inspector. And on the right-hand side, you'll see a few such fields here. So there's this notion of optional, which you can kind of think about as being, can this field be null or not, or is it required? And then there's this interesting field here, plurality. So too many relationship. In other words, if you want to make sure that a student can have a one-to-many relationship, and that's reasonable for a student who's, say, full-time at a school, let's go ahead and specify to-a-many relationship. And interestingly here, you can impose some constraints. 0 and 0 implies no such bounds, but you could say that no student here is allowed to take more than 4 courses, and we want to ensure that data constraint. All right, so let's go back here. Now let's go to a course and think about the world in the other direction. So a course has students. So this feels like it should definitely be another one-to-many relationship, whereby a course like this obviously has many students. So let's go about defining that relationship. Again, be careful not to put it under attribute if you actually want to associate one object with another. So let's go ahead and call a courses relationship students in the plural. This thing is going to point to one or more student objects. And let me now go over to the inspector and change that to a to-many relationship. And then just for good measure, specify a reverse mapping here so that it's clear to core data that we actually have effectively bidirectional arrows here. So under inverse, we're going to choose what for now is essentially the opposite of a student. It's a course. And then that will automatically populate itself over here for us. All right. So let's now go over to our remaining code files. There's not all that much going on as usual in main.m, so let's turn a blind eye to that. There is not all that much going on in the app delegate except for a few new properties. And so this hints at some of the underlying data structures that we're now leveraging. Thanks to our having started with a core data template and ultimately linking against it, you'll see recurring mentions of managed object context, managed object model, persistent store coordinator, the last of which you can think of as the database, the persistent storage that once this thing's installed on an iPad, iPod, or iPhone is going to be a long-term database in which if you store one or more students and one or more courses, even when the user shuts down that app, it's going to persist, much like a SQL database or an XML file that you wrote up yourself. Once you reload that application, you can assume that Alice and Bob and Charlie are still going to be in that database. So those properties are alluding to these objects that will get created for us. And as we'll see in the .m file here, there's a bunch going on. Looks a little messy as usual because of the font size. But notice that we're synthesizing those things up top. And again, this is just boilerplate code. We haven't written anything yet. This should hopefully feel familiar. We got our application did finish launching with options. We've got this mention of resigning active state and backgrounding and so forth. Most of this still seems to be comments. But there are a few interesting things here in the app delegate. Most of these commented out functions are familiar sounding, but this is interesting. We've not really spent much time in here just yet, but application will terminate. Stands to reason that right before the user kills or the OS kills an application that's running, maybe because the user's tired of it or because memory is incredibly low, well, you want to go ahead and save context. So this message passed to myself of save context is the equivalent of committing any changes you've made to the local database. What else is down here? Well, we've got a dalloc as usual, and you will see, again, those IVAR names there. Save context is the actual method here, a boilerplate code for which is written out for you. You can override some of this and actually exercise more fine-grained control if you want. But for now, I can actually get away with waving my hands at most of this because really, I can focus my attention just on the application did finish launching with options. So we'll do something simple here, but the goal at hand is going to be to now leverage this data model that we've defined using core data, and let's actually populate it with, say, at least a course, E76, and at least 2 students, Alice and Bob, and see what happens here. Yeah? Uh-huh. In terms of relational database, so you can think of it as giving you kind of the equivalent of a primary key, foreign key relationship, but it's not necessarily directly translated to that since the underlying data store can change, but that's a reasonable approximation so that there's some linkage between the two. So let me take the pre-baked cake out of the oven so that we can look at some of the otherwise tedious details to type in this same.m file. So I've done nothing else that I haven't already disclaimed. When wiring things up here, this is the same exact file, but with a prefabbed implementation of our application did finish launching with options. So let's take it away with Alice, just as we did a few weeks ago. A few new things. So first, I'm going to grab a pointer to this thing called NS managed object context. You can think of this as akin to opening a database connection, even though it might not be that per se. So now here's a block of code I've commented is related to Alice. So I'm going to go ahead and get an NS managed object. I'm going to call it Alice, a pointer there too. This is a very generic pointer to some piece of data that's been stored in the core data data store. So it could be a string, it could be an int, it could be an object. It's some kind of object, but I know it in advance is going to become Alice. So let's go ahead and create one such object in memory here. So we're going to go ahead and call, we're going to pass to the NS entity description class an insert new object for entity for name, and then specify that it's going to be managed by this particular context. Turns out you can have multiple such contexts, but for now, let's just focus on what we're storing in here. And this is going to be an object of type student. So you can think of this akin to calling a constructor or alloc or new or the equivalent and instantiating a student object who's destined to be stored in the core data storage. All right, let's go ahead and set some of those key value pairs that we defined as attributes before. Alice right now is kind of an empty object with no interesting data. So I'm going to set the value quote unquote Alice, which is going to be her name, indeed for the specific key called name. And that's very deliberately named identically to the attribute I defined a couple minutes ago in Xcode's GUI. Then I'm going to specify one other thing. I'm going to set as the value of the concentration attribute, which we also defined a moment ago, to be quote unquote computer science. And as we've gotten into the habit, notice that the @ signs there, these are NS strings that we're passing in. All right, let's do the exact same thing for Bob. With a wave of the hand, Bob will be Bob. Bob's also majoring by coincidence in computer science. But we notice we've created a second such object there. So now we have Alice in lowercase and Bob in lowercase, both defined as pointers to such objects. Now there's not all that much that remains to be done to actually create a course and associate those two students with it. So I'm going to go ahead and create another such object called course this time using the exact same syntax, but notice that I'm effectively instantiating an object of type course this time, not of type student. Recall that we gave a course a title before, and I'm going to call it computer science E76 down here. And now this one's a little more interesting because now I want to ensure that I have this one-to-many relationship. So I can't just call setValue twice, because as would be the case with most of these collection classes, when you call setValue, you're clobbering, presumably, the previous value. So we need to somehow store multiple students inside of, or rather map multiple students to this course object. So we can actually do that with a very generic container namely NSSet. You can't get away with using an array. A set, it's going to come back as an unordered collection of objects on the way out. So I'm going to go ahead and use NSSet. There's a convenience method in that class called setWithObjects, which takes a comma-separated, nil-terminated list of the objects you want to store in that set. So this NSSet, independent of core data. You might have used this in your own code along with NSArray, NSDictionary, and so forth. And I'm going to specify that that set of Alice and Bob is going to be mapped to the student's attribute, or really relation. Yeah?
What happens if I say make a typo in a table name string?
If you make a typo in the table name string, you will trigger an error in the debugging output because the core data model will detect as much.
So it will only happen at runtime?
At runtime, a runtime error, yes. Yeah, so you still have to be careful, but that sort of thing would not be checked at compilation time. Good question. All right. Now, this is a convention we've seen in C and also Objective-C before. It's a way of having a back channel where you get a return value. So I'm creating a pointer called error. It's of type NSError. I'm passing that in by pointer, thereby passing a pointer to a pointer here. The idea of which is that then, if there is in fact an error, the runtime can store inside a chunk of memory and then point to it, so that I then have access to whatever the error message is. And just in case something does go wrong for whatever reason, I'm going to go ahead and just print it out to the NSLog by calling localized description, which is just going to print it in, at least in this case, in English for me. All right, so at this point in the story, if we've actually run this code on an actual phone, initially the core database, if you will, is empty. At the end of this curly brace, we're going to have a course object in core data's model. We're going to have two student objects, and there's going to be this relationship between the two of them. All right, so now let's actually do something slightly interesting with them. So you can get a sense of now the equivalent of things like select. Yeah?
Are the keys, they're kind of arbitrary, concentration and so forth?
They are arbitrary. Harvard calls majors concentration, so I called it concentration.
At the time you're writing this code?
They are deliberately chosen. I deliberately chose them to be identical to the attributes I defined in Xcode before. Yes. So when I specified names for things, I have to remember, much like you would create a MySQL database, you have to remember what fields you've defined. Yeah?
What does context look like?
So context, if we again steal the analogy of the relational database, you can think of this as the database into which you're writing if you want to actually segment various data stores. So you connect to this database or this database, but you can have multiple tables in those contexts. The default one is yes. So you can actually manipulate multiple contexts, but here we're getting essentially what the default one is. All right, so let's just iterate over these things. All right, so iterate over courses, I claim. So in core data speak, we're going to go ahead and make a fetch request akin to a select statement in SQL. I'm going to go ahead and alloc and init that, and then I'm going to specify that what I want to get out of this fetch is an object of type course. And again, I'm specifying the same context, but those first few lines there are really just preparing the equivalent of a select statement, even though it might not be implemented as such. Then I'm going to go ahead and get my result set back, if you will, my fetched objects. It's going to be an array because I'm executing that fetch request. And now you have a little fast iteration. I'm going to iterate over those fetched objects, each of which is this very generic NS managed object for now. I'm going to call each of them info for now, info for a course, info for a student, whatever it might be. And I'm going to go ahead here and output the course's info, specifically its title. I'm going to then iterate over the students that are associated, presumably with this object, if there's one or more of them. Again, using some fast iteration, this time over the students that came out of the student's relation. And then I'm going to go ahead and use my old school NSLog skills and just print out the value for the student's name. And then parenthetically, these are just ordinary placeholders, I'm going to print out the student's concentration. So the end result, when I actually run this thing, is going to be, let's see, the following. All right, it's not all that interesting in the iPhone, since I didn't actually implement any kind of GUI or interesting output. But what we do see here is actually pretty darn compelling. We've stored, at least it seems to be, computer science E76, Alice and Bob. Well, let's go ahead and run this again now. Oh, interesting. So I've run it twice. I haven't reset the iOS simulator, so I've run really the exact same code again. So this hopefully shouldn't be surprising in that no matter what language you're using, if you execute the same insert SQL calls or create table calls in SQL, you're going to end up running them again and again. But what's interesting here is that we do now clearly have some persistent storage on the device. If I had actually burned this onto my phone and running it there, I would have the same data building up and up and up. And so we won't bother now going back to some of the more typical UI view manipulation, but you could imagine probably creating a iPhone-based form that maybe takes in some fields like a student's name, maybe a drop-down for the courses that they can take. You click Save. That then sends a message to some delegate, and that delegate's goal in life is to execute code akin to this, to actually insert a new Alice and a new Bob rather than the hard-coded boilerplate example that I walked us through here. Yeah? Yes. Yeah, so there are equivalents of updates and deletes and so forth. Let me defer to the student choice project if you want to go that route. But yes, there are equivalents for all of those things. And you can unlink the relations and whatnot. Yeah?
I was reading that I think it's possible to use a SQLite database underneath your core data. Not all, and I was looking at implementing that, but I was just wondering if it's the best practice to insert the data even like from SQLite into the core data model.
Oh, good question. So one, yes, I can confirm that SQLite can be used underneath the hood. And that's what's used by default to actually store the data that core data is managing for you. Can you import? You probably can if you have an existing SQLite database. If you then construct the various relations in core data and then point it to that file. I've not done that myself, but I'm guessing there's a mechanism in place for imports. But SQLite is just one of the options, but among the more performant.
What's the best, I guess, format to import into core data if you were taking it from an external file?
Oh, well, I mean, you don't have terribly many options to import it. You would have SQLite XML, and there's one or two other options. So I would only go through the process of conversion if you think that this is actually going to solve some problem you have, perhaps the amount of complexity in your current code, the number of lines of code you have, the number of SQL queries you have. One of the goals of core data is to actually reduce the amount of code you have to write, reduce the number of queries you have to write, the relationships that you have to keep around in your head, because we didn't quite look through the whole attribute inspector there, but there are constraints you can impose like cascading deletes, much like you can in SQL and so forth. So a lot of the complexities or headaches involved with managing all of your tables yourself can go away. So if you do have an existing SQLite database that's kind of getting out of control, which to be honest probably isn't for an iPhone or a mobile application just yet, you could in theory though move it over. But if you've got code working, frankly, you're just creating more work for yourself if you convert it over to this and throw away all the code you already wrote unless it's solving a problem for you. Yeah. Oh, just a shake. All right. So an option then, consider it for this remaining student choice project. So how about localization? So we took a look at this in the context of Android, and it turns out that in iOS, it's actually really easy, when Xcode cooperates, to localize your application, generally using the GUI. And then you can even use a number of command line tools if you really want to localize your application with a bit more efficiency. So this is the sort of thing, let me suggest, that if you are intent, either for the course or beyond the course, and actually writing an application that's going to be distributed in your company or distributed via the App Store, and you legitimately think that you would want to have multiple languages supported, do it now. Don't go back later and do it, because it's relatively easy to do now. It's a relative headache to go back and change all of the strings you've hard-coded throughout your application later. Even if you've just got one language, English, from the start, you can at least lay the groundwork for embedding other such tools. So let's go ahead and do this. I'm going to close that core data application. I'm going to open up a blank Xcode template. And I'm going to go with view-based application now, just so that we can start taking advantage of screen rotations if we care about, and just some of the helper functions that come free with that. I'm going to call this one, let's say, ciao 1, hello in Italian. I'm going to go ahead and target the iPhone, only because it'll fit nicer on the screen. I'm going to hit Enter. And now I have a blank project called ciao 1, and I'm going to demonstrate how we might localize this application. So first, let's implement the very compelling English version. I'm going to open up my view controllers nib file. So not main window.nib, but the view controllers, which is the one I'm actually going to see. I'm going to open up my little inspectors over here. I'm going to find that UI label. I'm going to go ahead and type in here, hello world. And just to be anal, I'm going to go ahead and center it here and grow this over here. And then go ahead and center this there. All right, that's all you're going to get from me. That is my English implementation of Ciao. And let's go ahead and test it. Works great. All right, how do I go about localizing this application? Because now I actually want to ship this into the Italian App Store. All right, well, I could create a whole new project. I could give it a different name. I could do sort of unproductive things like that. Or I can do this. Let me go ahead and click the Ciao1 viewcontroller.nib again. This time I'm going to go over to my, come on. This time I'm going to go over to my file inspector at top left there. And now notice all this while there's been this little submenu called localization. Right now it only specifies English, just because it's assuming that's what I'm writing in. Let me go ahead and click the plus sign here. And I get a whole bunch of seemingly popular languages plus a submenu with even more languages. Let's go ahead and pick Italian here. Notice Italian appears in that localization list, but notice slightly more interestingly on the top left, now this nib file seems to have become a folder of nib files. And indeed, what we've essentially gotten now are multiple nib files. So let's expand this little triangle. And indeed, I have one in English, which looks just like it did a moment ago. And then I have one in Italian, which actually still looks like what it did before. So let's go ahead and localize this application. Ciao mondo. Enter. Now, just to demonstrate we've changed only one of them, I'm going to click back on the English. Hello world. Ciao mondo. So now I have two variants of this, both of which are associated underneath the hood with the various language and or country codes. So one of the things that Xcode 4 has done versus Xcode 3 is hide some of the underlying details. But if I actually go into this project folder, which is currently on my desktop, we'll see in here that there's now mentions of this .lproj folder, both for EN for English, IT for Italian. And so in there now are the localized resources. Now, even though I'm just doing this for the nib, you can actually do some pretty neat things with just arbitrary files. For instance, if this is like a foreign currency exchange program or something like that, which has the flags of the world, well, you could put a flag.ping in your English folder and then an identically named flag.ping in your Italian folder. And then the program, based on the language settings on the user's iPhone or iPad or iPod, will actually choose one of those graphics for you selectively, much like the nib would be doing for it. But you'll see if you read through online resources and or textbooks that there will be more mentions of this than you see in Xcode today, because some of those details have been now abstracted away. And so all we now see in Xcode 4 for this stuff is the parenthetical on the top left here, English and Italian. So just realize the disparity if you're reading up more online. All right, so let's go ahead and run this. Yes?
What if I want to localize a bunch of strings, like error messages? Is there something like resources?
Good question. What if you want to localize a whole bunch of strings? Yes, and we'll do that in version 2, because we'll quickly see that this does not really scale if you have to redo your entire GUI just to localize it, especially if some of your strings are coming programmatically from code.
Is there really just one label?
In a typical application, no. This is underrepresentative.
Suppose you take the Italian one and you move the label to the top and turn the background blue.
Oh, good question. So what if you make changes to one, not the other? They actually do start to get decoupled. So again, reason number 2, not to necessarily go this route. We'll see a more powerful, more versatile programmatic way in just a moment. All right, so let's go ahead now and run this. All right, so I'm going to run the simulator, which by default is in English. There is my Hello World application. So now let's go ahead and change this. So for those unfamiliar in the iPhone, I'm going to go back to the home screen here. There's Tommy from last week and all my blank games from last week. Let's go over to Settings and go to General and go to International. And you have a couple of language-related options here. One is the region format, which means you might be a Spanish native speaker but living in the US or vice versa, or any number of country language combinations. For now, I only care about the language, so I'm going to go ahead and click on Language. Then I'm going to scroll down to Italian. I'm going to click Done. And a few seconds later, it's going to have changed my lingua to Italian. It's unclear why it takes this long. but now, now the simulator crashes. So this was actually pretty consistently produced by myself and some of the teaching fellows. Seems to be an issue when you're running it in the simulator or with the USB cable attached, presumably because the debugger, JDB, is attached. This actually works perfectly fine when you disconnect your USB cable or reset the iOS simulator. So I do that so that you can perhaps save the hour of time I spent trying to solve that when there seems to be no current solution. All right, so the output is correct. Just don't do it in the simulator or with your USB cable attached. So let's do this. With a wave of the hand, as though that never happened, I'm just going to, well, there we go. I don't have to reset. I went ahead and rebooted the simulator, the exact same code, and voila, now it's ciao mondo. And we can see that same crash again if I change it back to English and then reload the simulator. But resetting the simulator at least, or not using your USB cable, should avoid that issue. All right, so at this point in the story, my questions were going to be, well, what's bad about this approach? All right, well, we kind of realized that already. One, this doesn't really scale, especially if you decide to make non-trivial changes to your GUI later on. After you forked off the Italian version, maybe the French version, the Spanish version, now you have to make these changes in all sorts of places, which is really runs afoul of the idea of trying to design this thing well. And two, what if some of your output, like many applications we've written, Evil Hangman, for instance, is not coming from these hard-coded strings in Interface Builder, but you're rather generating them programmatically based on user input. So we need some way of actually doing this in C or an Objective-C code. Well, let's go ahead and take a stab at that. I'm going to go ahead and close chow1 as being suboptimal here. I'm going to go ahead and open up a new project, view-based application, call it version 2, chow2. And I'm going to hit enter and save it on my desktop as before. And now let's go ahead and do this. So now hopefully these are motions you're getting more comfortable with now. I'm going to click my viewcontroller.nib. I'm going to open my view inspector here. I'm going to drag a label again over here. I'm going to move this over here, this over here. But for now, just to be clear that the changes are coming from code and not from hard-coded strings, I'm just going to leave it called label. All right, so now I'm going to go over to my viewcontroller.h, and I want to go ahead and wire this up. So I'm going to go ahead and define a property with non-atomic, retain, and I'm going to make it an IB outlet, so I can now interface with my interface-built GUI in code. So this should be of what type? Little sanity check? Yep, UI label, and we'll call this just label. Now I have to go over to my M file, and I'm going to go in here and synthesize this. I'm going to call it label. I'm going to map it to an IVAR called label. OK, so that part's done. So now I can go back to the nib. I can drag from what to what in order to wire my code to my GUI. Yep. From files owner, which in this case is the view controller.h and .m. So I'm going to control click from files owner to the UI label. It then starts to highlight. I let go. I have a couple of options. One is the view that I got for free. One is the label that I defined. It double flashes, which I save it. Now I have a programmatic connection to this thing. So now let's go ahead and do this. I just want to keep it simple. So I'm just going to choose a method that does get called once this application is running. This application doesn't need to do much. So I'm just going to keep it simple and go to view.didLoad, which is the point at which the view has loaded into memory. It doesn't necessarily displayed yet, but I'm going to go ahead and change now the contents of that label. So I'm going to say self.label.text gets quote unquote, let's say hello world. All right, so not exactly localized, but at least we should have a working program. So let's go ahead and do this. OK. So good. So now we're kind of back where we were 3 or 4 weeks ago, even if now at least it's starting to finally feel easy. Well, now let's go ahead and localize this. So I'm definitely not going to change the nib this time, because the nib doesn't even have hello world. It just has the keyword label. So I need to have some layer of indirection now between my strings and what's actually getting and the localization thereof. So how can I go about doing this? Well, I'm going to do this. There's a few ways to go about it. But I'm going to use a somewhat familiar technique that we've used a few times. I'm going to right-click or control-click on my project or one of the groups there. And I'm going to choose Add File, or New File, rather. And then I've got all these options as usual. Make sure to click on the iOS part up top because the templates are slightly different. And I'm clicking through, oh, there it is, resources. So there's a bunch of resources. You might have started playing with the settings bundle if you have considered doing that for your student choice. But recall for Evil Hangman, you're not using a settings bundle. You're using the reverse side of a utility application. Property list we looked at before. You can include a rich text file with fancy formatting and whatnot. I just want a strings file so that I can localize my strings. I'm going to go here, hit enter. What do I want to call it? Localizable.strings. Very deliberately named to be consistent with what iOS is expecting me to call this thing. So localizable.strings. I'm going to go ahead and hit enter. Go back to my file explorer, and there it is, localizable strings. If I click it, it's just an empty textual file now. It happens to be in UTF-16, so you can support all sorts of languages in this file. But now I have a placeholder where I can start localizing some strings. So how do I actually use this? Well, I need to define some key value pairs, but I also need to specify what languages these key value pairs are actually in. Right now, it's actually just assuming English, or notice it says no localization, so English is just assumed. So just as I did with the nib file, I'm going to click on localizable.strings. I'm going to go over here on the right-hand side. I'm going to add a localization. This is just a quirk of Xcode. Nothing useful seems to have happened. Nothing even appears in the list. But if I now go back, it's been deselected for no reason. Select it now, there it is. So now we have English defined. But notice there's no caret symbol next to the file yet, because that's because we haven't defined Italian, Spanish, French, or anything. So let's do the same thing. A plus over here. Let's do Italian again. Now Italian appears there, which means Italian should appear over here. And voila, now I have two empty files. And the nice thing here is that I don't have to worry as much about keeping these two things in sync. Now, you don't have to anticipate all the possible languages in advance, though if you play around with that plus symbol, you'll actually see there's a little convenient option that says, give me all languages, if you're actually going to be that ambitious. But for now, it suffices to at least have the English one or English and something else, so at least the foundation is set for doing this in the future. So now I need some key value pairs. I'm going to do the English one first. And I'm going to say that the keyword greeting, and this could be anything, is going to map to hello world. So notice a couple things. You can think of this more like preprocessor type directives. So the syntax is slightly different from Objective-C. There's no mentions of @signs in this file. There is a mention of a semicolon there. But really what we're defining in this file are key value pairs. The keys are going to be on the left, the values on the right. Capitalization I just chose as a convention. Doesn't need to be that way. But I'm going to do now something very similar in the Italian version, where the left-hand side is still going to be greeting, because I, the programmer, speak English, and I want it to say greeting. But I'm going to change the value to be ciao mondo there. So now we just have to somehow do a lookup in this file such that both end up in the outputted executable. So I don't want to just hard code hello world anymore. I kind of want to do this in spirit, but have greeting resolve to either hello world or ciao mondo. So how do we do this? Well, we have a little helper function. It's actually a macro. And what I'm going to do is ns localized string. Notice it takes a key and a comment. So the key is going to be greeting. So again, I'm writing Objective-C now. This isn't a special .strings file, so I keep my NS-string conventions with the @sign. The comment is kind of interesting. It's actually not going to be useful for the exercise at hand, but I'm going to go ahead and just give it a comment. Oh, I violated my own rule. Greeting for user. So what's this going to do for me? Well, right now, it suffices to assume that NS localized string is going to do a lookup in any number of your .strings file based on the language that's set on the user's own device. It's going to find this key. It's going to replace it with that value. And as for this comment, this is actually useful for the developer. So it's kind of annoying and tedious if you have to keep going back and forth to your strings file, defining these things one at a time. And frankly, it takes the fun out of localizing your application and rather raises the bar. Well, there comes with Mac OS and with the SDK a number of command line utilities. One of them is called gen strings, one word, G-E-N-S-T-R-I-N-G-S. And what this tool will do is if you pass it one or more command line arguments, namely all of your .m files or all of your .h files, it will grep through them looking for all mentions of NS localized string. It will figure out all of the keys that you've specified in your code. It will also grab all of the comments and then generate for you a localized .strings file that looks something like, quote unquote, key equals, let's say, value. And then atop that, it's going to say comment that programmer wrote. So it's just going to generate line after line after line after line the lookup table that you might want to then fill in. You can then ship these .strings files via email to your translators abroad or wherever, and they can just fill in the blanks for you.
So semantically, it seems that these comments are just annotations. They are not really used
Exactly.
at runtime.
They're just annotations, not used at runtime.
Why are we then specifying them as values for the system to have at runtime?
It's a good question, and it kind of rubs me the wrong way too. So for the camera, the question is, if these comments aren't actually used at runtime and really don't belong in my source code per se, it's rather meta information that should be used by the equivalent of JavaDoc or whatever the tool is that's pre-processing this, why do we pass them as the second argument? It's just because someone decided to do it that way. NS localized string is a macro that takes these as input, so it doesn't actually end up in the binary, the comment string, because it can be mapped away thanks to the preprocessor. But to be honest, I will admit it would be nice if there were a version of NS localized string that didn't even take a comment, because for small scale projects, you know, if I don't want to put comments, why should I have to? But in this case, you do quote unquote if you want to skip them altogether. Yeah.
Couldn't you do the same thing by defining your own macro that called in a string with an empty type?
Sure, you could absolutely solve this problem yourself by writing your own macro that only takes one argument, but quote unquote is pretty easy too. As much as I complained just now. Yeah.
Can you handle any other types, like not just strings, but can you localize numbers or dates, for example?
Oh, good question. Can you localize dates, numbers, and so forth? So you actually can. There's a class called NSLocale, which is the interesting one to look at, that gives you access to the formatting codes that are used by various regions, various countries. We in the US might do month/date/year. Abroad, they might do date/month/year. So you can gain access programmatically to the default formatting codes and such, and the current regions and all of that locale-specific information via that class called NSLocale. So yes, you do have access to all of that. Generally, the data would still be the same. You could still create an NSDate using your own country's preferred formatting, but render that to the screen with the help of this helper class. Good question. Other questions? Yeah. It's okay. For the core data example in class, I chose the simplest, the window-based application, so that we would have no distractions other than the additional core data stuff today. But we could have used some of the other templates as well. Any questions? Yeah.
How do you get extended character sets in there?
Good question. So the file itself is UTF-16, so it's encoded properly. If you actually want to embed the right characters, you could use, I mean, even in Mac OS, there's a screen overlay keyboard so that you can actually punch in the symbols that you want to create the right characters. I know relatively little about other keyboard mappings that folks tend to use, but at least with Mac OS, you can input it manually yourself, or if someone else gives you the text file in the right format, you can just drop it in as well. I've used those simple keyboards for like Italian and Spanish accents, for instance, to save because I don't know the keyboard shortcuts. All right, so after break, we're going to dive into core graphics and animation, and we'll actually implement an age-old favorite game, and we'll do this by not using some of the built-in widgets anymore, but by actually drawing our own shapes on the screen. So I'm going to take our 5-minute break. All right, we're back. So JP proposed a useful trick if you actually want to see what's going on underneath the hood with core data, assuming you're using the default SQLite backend for it. So it's a number of steps away. So I will give you a little teaser here, and I'll post a summary on the help board or a screenshot if I can get it to stick. But what I just went through were the following steps. For my core data application, I was just curious to see the SQLite database and then look at it in the SQLite 3 tool or to load it into any other SQL management tool. So I went to my home folder, Malin. I went to library, application support, iPhone simulator, the version number, 4.3, applications, the unique ID that represents that particular application. Easy trick here is if you reset the iOS simulator, you're only going to have one such key, so you can figure it out, as I just did. And then in documents, will you see, you can pause the video at this point in the lecture if you need to repeat those steps. You'll see core data.sqlite, and you can then actually futz around with that file if you so choose. But again, this just hammers home the point, hopefully, that core data is just an abstraction on top of that. Yeah? Good question. Is it assumed that each table is an entity? I would think with high probability when you're using the SQLite engine. You shouldn't care about that, to be fair, but if you are trying to go from one to the other, that could certainly be germane. All right, so very excited, because this is a really fun game. So this is one of the earliest games, Pong. It's sort of the equivalent of table tennis on a computer. What's nice about it, though, is that you can use fairly limited graphics, even though we have like a gigahertz worth of computing power available to us. I'm going to do my best to see if I can't implement this from scratch correctly the first time around. But it'll actually offer us a really nice opportunity to, one, revisit some of the wiring that we've been doing with IB outlets of late, to revisit some of the view controller discussions we've had, but to transition away from using some of the built-in widgets like labels and images and so forth, and instead actually make our own graphics, 2D graphics for now. But know that the iPhone does support OpenGL ES, which is the embedded version of OpenGL. That in and of itself tends to be an entire course, but if it interests to you, certainly for your choice project, you can find any number of resources online. We're going to focus on the API or the SDK generally known as Core Graphics, part of which is this thing called Quartz or Quartz 2D, some of which we've actually used but briefly over the past couple of weeks. So you might see some familiar prefixes and or functions. So this is the game according to this Wikipedia archive here. So you have a screen, a tennis court of sorts. You have just a midpoint. You have a score for the person on the left, a score for the person on the right. You have two paddles, one of which is controlled by the computer, one of which will be controlled by me with the equivalent of a joystick or my up, down, left, right keyboard, or in the case of a touch device with my finger this time around. So our goal is to implement that, but surely you can imagine a sexier interface, actually lay down some grass or whatnot, but we're going to keep it super retro for today's purposes. All right, so what do we need to know before diving in here? Well, one, just let's make sure everyone's on the same page as to the coordinate system. This actually differs in OpenGL, where things are a bit reversed. But for our purposes now, with our 2D graphics, the top of our world is going to be the top left-hand corner. That's 0, 0. The x-axis will go to the right. The y-axis will grow downward. So plant that 0, 0 in your mind. Two, this notion of frames we're going to see. So there's frames, there are bounds, and there are centers of UI views. So this is actually from Apple's own documentation. So I imagine this is some happy Apple engineer. And what you have here is, let's say, a UI image view. If you've ever embedded, like we did last week, a Tommy or equivalent into your application using a UI image view, you had a rectangular object like this. Now on the left-hand side here, the context is a discussion of what's called the frame. And the frame is generally the parent container for any such subview, like a UI image view. In other words, this guy here is actually at pixel core. It's offset from the top left-hand corner, 40 pixels in and 40 pixels down. And then it has its own width, 240 pixels in this case, 380 pixels in this case. So the frame includes all of that, including the padding around the top and the left. Now, if you focus only on the guy, irrespective of his parent container, the whole window or screen on the iPhone or the iPad, well, his bounds are actually independent of that initial offset. So generally, when writing code where you're manipulating things inside of a UI view, inside of a rectangle, you need to realize that they're relative to the rectangle in which you're in. So there's no mention of 40/40 on this one. Anytime we use the keyword bounds, as we'll see in code, we're going to be talking only about the relative coordinates within the view, irrespective of where this thing actually is on the screen.
So the center within the bounds rectangle would be, what, 120 by 190 or something?
Yes, so correct. So the center here would be 120 by 190, whereas the center there is actually relative to the parent frame. A good point to make. All right. So points, finally. So ever since the iPhone 4 came out, those of you with the iPhone 4 actually have twice the resolution, twice the pixel density on your screen. This would create havoc if this now meant not only do we have to support the iPhone and the iPad, we now have two different versions of the iPhone, and so we now need multiple views or multiple copies of our application, each of which supports the different resolutions. Thankfully, Apple kept it relatively simple, whereby you can assume that the dimensions of these three classes of devices are still 320 by 480 in the case of the iPhone 3, 3G, 3GS, iPhone 4. And then in the case of the iPad, it is different, 1024 by 768. But notice that there's no mention of pixels on the screen here, but rather points. A point is not necessarily equivalent to a pixel. So it turns out that the number of pixels on the iPhone 4 is actually 640 by 960, so twice that resolution, but it still has the same number of points. So this is useful because certainly when we're drawing 2D graphics, we don't even have to know that the iPhone 4 has this super duper retina display with higher resolution. It just so happens that 1 pixel on the iPhone 3GS will just so happen to be 4 pixels on the iPhone 4. It will just scale up for us. So all of the mathematics we do, all of the pixel coordinate, sorry, even I'm doing it wrong, all of the geographic coordinates, if you will be in points, not in pixels. Yeah? Good question. Does that make animation choppier on the latest device? Potentially. There are ways to ameliorate that. In fact, there's a different SDK altogether, namely OpenGL, where you can do much fancier transitions and you can have much more fine-grained control. But yeah, and you'll see even in our Pong implementation that the little ball will actually have a little ghosting on the screen here if it shows up on the projector. Yeah?
So judging by this resolution that you have here, can we assume that on the iPhone, iPod Touch, the default view is like portrait and on the iPad is landscape?
Good question. Based on these resolutions, should you assume one or the other? No, to be honest, as I look at these numbers, I should have written one of them the opposite to be consistent. If anything, the default view of an iPhone or an iPad is up vertically, just because the home button is on the bottom. So I accidentally reversed those two. So I'll fix this as though it never happened. But you shouldn't assume anything. As we've seen in our various UI view controller classes, you, the programmer, can specify exactly what orientations you want to care about and actually support. So, all right. So let's dive in. I'm going to go over to Xcode here. I'm going to go ahead and create a new project. I'm going to use a view-based application because I do care about screen rotations here. I'm going to keep it simple, though, and I'm only going to support one landscape orientation, but we could add support for others, but we'll focus more on the graphics aspect today and less on the UI view controller stuff, which we've encountered before. I'm going to go ahead and call this Pong. I'm going to go ahead and hit Enter, save it on my desktop, and let's see where we can begin here. So hopefully this stuff at the top is pretty familiar now. We have our nib files, we have our m files, our h files. I'm going to go ahead and first do this, and this is one of these things that certainly could be clear. This does not mean that those are the orientations your app will support. That means the list of orientations that ideally your app will start in. And so by whittling this down to just one, what the runtime should do for me is that when I boot it up, it should open up in only that orientation, but it's still in code, recall. In our view controller, we need to specify by returning yes or no, a Boolean value, which orientations we actually care about. So it's so enticing to just think it's that easy to deal with orientations, but not quite just yet. So I'm going to go ahead and save this. What do I want to do next? Let me go ahead and go into my nib file for Pong view controller. And I am going to change the orientation here just so that I can map this out. So if you've not used it before, if you know you only care about one orientation, you can go ahead and change that explicitly to landscape. Recall that we did play with those things called springs and struts a couple of weeks ago, where you can specify the little red lines that say should your labels grow or your buttons grow or recenter themselves. We're not going to bother with that. This is a game, and a lot of games just force you to use the device in one orientation or another. So here now is our layout. I'm going to bite off the simplest things first. I want my Pong background to be black. So that's a pretty good step forward there. And let's go ahead and get a slight sense of gratification and run this thing. OK, so not bad, but clearly broken. So what do I need to change here? even though I clicked that very obvious and enticing button to say landscape mode. Yeah, so in code, I actually need to specify, I actually care about this one. So I'm going to go into my Pong view controller.m. I'm going to scroll down to the should auto rotate to interface orientation, and therein lies the reason for the vertical default. I'm going to go ahead and change this to landscape right. And I could return true or yes for others, but let's go ahead and just fix this. OK, good. Baby steps. Now, one more thing. Now, Pong, I'm pretty sure, doesn't have an AT&T signal and a clock and a battery. So let's get rid of that next. You can do this in code, but it's actually relatively easy to do with a property list here. I'm going to go to ponginfo.plist. And you have a whole bunch of default values here, including, for instance, the name of your application, version numbers. And for those of you who have actually applied for certificates through the course, you'll notice mention of edu.harvard.product name. And that is your part of your application ID or your bundle ID. So down here, notice that this is somewhat non-obvious. But you can either right-click on the blank part and choose Add Row to add a key value pair to the textual property list that actually we're looking at here. Or for some reason, you can click the plus sign that appears in the bottommost row, and you'll get another such row. And then here, you just kind of have to know what you're looking for, or you have to read through all 50 options. And I rarely remember what I'm looking for, so I'm going to read through them. And it's called status bar is initially hidden. So this is one of those things, too, where someone thought it was a good idea to simplify it into human readable English. But now I tend to know the constants names, like the UI ... a little better. But what you're seeing now is the slightly more human-friendly version. But thankfully, this does say what it's going to do. Status bar is initially hidden. It's apparently a default. It's a Boolean type. I'm going to go over here, choose yes from the dropdown, save it, sanity check. I'm going to rerun it. OK. On my way. And again, this is actually not a bad approach, especially if you like those little pats on the back that things are going well. It also means if something goes wrong, I know that I did relatively little to get to that point. So now let's actually start implementing Pong. So I'm going to go over to my nib file here. And I need to now implement, let's say, the ball and the paddle on the left and the right. And I'm going to cheat. I want to at least get something up and working. So I'm going to use overkill, a very heavy-handed, and I'm going to make my own paddle and my own ball to embed in this game. So this is Photoshop and very unrelated to Xcode, but I'm going to go ahead and make an image that's 10 pixels by 10 pixels. Okay, at the very top left, this is going to become my game's ball. I'm going to go ahead and save this as, and I'm going to go ahead and save this as a ping, and I'm going to call it ball.ping. I'll save it on my desktop for now. OK. All right. Now I've made my ball. Frankly, that will save me many minutes of Xcoding here. Let me go ahead and create now the paddle, which I'll reuse for both players. Make it an arbitrary height of 60 pixels by 10 wide. So my paddle is going to look a little something like that at the very top left. Let's go ahead and save this. Let's go ahead and call this paddle.ping. All right. Done with Photoshop. That just saved me a whole lot of 2D graphics. But we'll... Oh, that's true. So that's true, but I'm going to get rid of these pings before long anyway. So point taken, but we'll keep it even super simple and just save it as is. So now we got to get these things in here. So these widgets we've used before. So let me just scroll down. And again, I promise we'll get rid of some of these. So I definitely don't need a UI image view that big, but let me just lay it in there. I'm going to choose at top right the default image. I don't seem to have any options. So this is the point at which, recall, that if you want to import some things into your project, click the ball, click the paddle, and let me drag them over to, say, my supporting files. But they could go really anywhere. Just like we've imported files like the controller file from other things before and so forth, make sure to copy it over in case you delete the one that's sitting on your desktop. All right. Now they're actually in my project. Notice them at top left over here, paddle and ball. So now, if I'm in my nib, I can specify that the contents of this image view are going to be either ball or paddle. That's going to be ball. Now, this is a little excessive. I definitely didn't make that image. So let me actually change it from scale to center. All right, that looks a little more like the 10 by 10 ball that I drew. And actually, I know it's 10 by 10. So for now, I'm going to make it 10 width by 10 height. And now we've really whittled it down to something pretty small. I'm going to very carefully drag it to the center, so the game starts with it centered. And now I'm going to do one thing and a little copy paste. So I'm going to load into this guy the file called paddle. All All right, that too is getting stretched unnecessarily. So let me go ahead and make him 10 by 60, as I know he is. But this too is still, let's see, technically scaling. So just to be proper, we'll make it centered. I'm going to move this left paddle over here. I'm going to copy and paste it. Move this right paddle over here. You know, we're halfway to implementing Pong, frankly. All right, so now we're just going to have to animate things. And eventually we'll replace these rectangular pings with actual rectangles that we'll draw ourselves. And you'll see in section today with Tommy that beyond simple rectangles, can you do interesting things with gradients, triangles, circles, curves, all sorts of things in 2 dimensions. Well, now let's at least give ourselves the ability to start moving things around. Let's get that ball moving back and forth. So I want to start talking programmatically to the ball and later the paddles. So how do I generally do that? IB outlets. All right, so let's do that real quick. So I'm going to go to my Pong view controller.h. So again, the only thing I've done so far to recap is I've dragged and dropped my pings into my project and I've edited the nib file. Now we're editing the .h file. And I'm going to specify a property of, let's call it a property, which is going to be, come back to that. It's going to be type IB outlets here. And then UI image view. Careful that it's not an image. It's actually an image view. We're going to call this the ball. I'm going to go ahead now and ask you the question. What goes here? What attribute should we apply to a UI image view? OK, so we want it to retain because it's going to be a pointer to an object. So generally, we do want this retain semantics. And yeah, non-atomic. We haven't really dealt with multi-threading here, so non-atomic is fine. It gives us a slight performance benefit because we don't worry about locking or semaphores. So now let's go ahead and create 2 other things for the paddles. This is going to be paddle left, let's say, and this will be paddle right. All right, Xcode's already yelling at me with these yellow flags, but that's only because I haven't synthesized these things. So let's quickly do that. Synthesize a thing called ball, map it to underscore ball, synthesize what do we call it? Paddle left to underscore paddle left. And then copy paste. Change this to paddle right. Change this to paddle right. All right, so now we're on our way. So pretty good so far. Now I have programmatic access to those things. So now I want to actually start moving things around. So even if you've not really dabbled in graphics or game making before, just what would be one approach to moving that ball around on the screen? And again, the goal of Pong, if unfamiliar, is the thing just literally bounces around on the screen and you try to hit it with the paddles. Yeah. OK, so we've seen transforms. We've seen affine transformations last week where we were able to scale or translate things on the screen from one point to another. So that's one tool in our toolkit. What else could, and translating it, though, will move it, or could scale it out, but could move it. But we don't want it to just move once, right? We want this to keep happening. So in simplest form, how do you implement animation?
Well, change its position in its containing view.
Yeah, so we could change its position, its containing view. So that's actually a perfect way to tie in this picture that we painted earlier, which was we have this containing view, the whole screen, aka the frame. This little ball has a center. It's a UI view. It has a center whose coordinates by default are going to be centered in the screen here, just like this guy here. So granted, without the offset and with the screen rotated. So in theory, what if just every second or so we move the center of the ball to be here, 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 here? And actually 1 second would make for a pretty lame game. So what if we do it every 0.05 seconds or 20 times per second, 20 frames per second? We can move this thing around and create the illusion of animation, much like an old school flip book that creates the illusion of like a movie, but just out of pieces of paper that are flipping by very quickly. So we need to set some kind of timer, it would seem, and actually keep track then of where this thing is so that when we hit the edge, top, left, bottom, or right, we don't want it to just soar off into nowhere, thus ending the game. We want it to actually bounce. So we have to think back now to sort of high school geometry and reflections, or just playing pool. When it hits the wall, you want one of its directions of its motion to actually flip around based on the angle it strikes. But we'll keep it simple here. So I'm going to go ahead and scroll down to my M file, and let's see what some of our options are here. We've got a dealloc method, so we should actually do, for good measure, something here. We should actually send a release message to the ball, and we should actually send a release message to the paddle, and we should actually send a release message to the other paddle. And why do I send release, even though I didn't call alloc?
Because they retained.
Yeah, I did call retain, albeit implicitly, because I defined those properties as having the non-atomic but a retain attribute as well. That means the setter I got is going to call retain when the nib is unserialized and loaded into memory. A retain is going to get applied to each of those three objects, and so when this whole controller is unloaded at the very end of the program, I'm supposed to pass it a release message. Now, as you might have seen on the bulletin board, dealloc is not always called. So if you actually put an nslog message in there and actually try to print dealloc, it might actually never get called even if you force kill your application. This is generally just for efficiency reasons. iOS figured if you're quitting the application, who cares if we pretty everything up? They can just zero that memory anyway, irrespective of all the little objects that might be living in it as well. All right, well, what else should we do? Well, to be proper, we should also take to heart some of the comments in here. So it says release any retained subviews of the main view. So just in case, now granted, this program only has one view controller, only one view. But in theory, if when it's backgrounded, that view's got to get punted from memory and reloaded from the nib, really I should be getting into the habit here of saying, well, self.ball, I'm going to go ahead and set that to nil if the view is unloaded. Self.paddle left is going to be set to nil. Self.paddle right is going to be set to nil. I could pass release messages to these things, but generally the pattern is to still use your setters and getters anytime you're inside of the class in these methods here, and only in dealloc to use the ivar. But if this thing is punted from memory because of low memory situations, or it's backgrounded and I'm doing plenty of other things, it will be reloaded properly from the nib anyway, and all of those connections will be reestablished. So we don't have to worry about view did load, at least just yet. All right, so where do we actually want to load some things? So this is one of these decision points when it comes to the design of a program. Where can you actually load things? You typically have init methods, init with frame methods, init with coder methods, awake from nib, view did load, view will display. And there's so many damn options sometimes. So let's actually go to the one that we know at least guarantees that all of those outlets in our nib file have been established, so that if we start touching pointers, we're perfectly safe. And so that method, which gets passed anytime an object is deserialized from a nib file, is simply called awake from nib. All right, and in this method, you can think of this as one of your options for actually doing some initialization for a controller. I'm going to go ahead and do at least one thing. I'm going to go ahead and specify a message to the NSTimer class. It's going to be a scheduled timer with time interval, and I'm going to specify 20 frames per second, or go ahead and fire this message every 0.05 seconds. And let me go ahead then and pass in here, let's say, oh, not this one. I let autocomplete get out of control. All right, scheduled timer with time interval. There we go. So I want to go ahead and specify 0.05. I'm going to specify a target of myself, what selector. I'm going to go ahead in a moment and implement a method called play. And that method doesn't exist yet. Is going to be something I write that just moves the paddle and responds to any touches from the user. As for user info, I'm not going to care about that. And repeat, whoops, nil here and yes here, because I want this timer, much like JavaScript's window.setTimeout, I want it to fire again, or set interval rather, I want it to fire again and again and again. So here's a way, long story short, of scheduling a timer that's going to run infinitely long, and every 0.05 seconds it's going to call a method, namely play, and it's going to pass the play message to myself because of the target that I've specified there. So that means I get to do something like this. I'm going to go ahead and define a method called play. I'm not quite sure what it's going to do yet, but at least now I know that this thing is going to get called again and again and again. So let's do our little sanity check here. And I'm going to say play to nslog. And hopefully, if I've scheduled everything correctly here and run this thing in the simulator, OK, that's pretty good. And you can see that a bunch of times per second, this thing is actually firing and logging down here, even though I'm not doing much of interest. All right, so what do I want to do next? Well, let's go ahead and implement the movement of this thing. So here's what our interface looks like. The goal is now to simply have the ball moving around and bouncing around, but also detecting whether or not it's on the edge. So this actually boils down to some relatively simple logic, and nothing all that much fancier than what we've been doing before. So I'm going to go ahead and start off with, let's say, very simple movement. Let's at least move this thing. So move ball. So how do we do this? Well, we know from our PowerPoint presentation there that at least every UI view has a center. And by default, I specified that in the nib, and I dragged and dropped it, got the nice little guidelines, and it's dead center. So we know where it's going to start simply because of the nib. But I can certainly move this programmatically because I've defined a property called ball. I have access to that property called center. And actually, let me let the AutoSense here show us something useful. Notice that the center property is actually a CG core graphics point. This is simply an XY coordinates with floating point values, and with floating point values. Is that true? We'll take a look in a second. In the center is going to be where we can update the actual coordinates here. So how do we actually do this? Well, we can actually do CG point make. And here's the curious thing. We're actually using C functions. So core graphics is a C library. So you're going to see some occasional commingling of Objective-C with C. This thing, even though it's called make, it's actually just returning a struct. So it's not allocating any memory. There's no use of malloc or whatnot. It's just returning a finite amount of memory, which has two fields in it, X and Y for the size. Well, where do I want to move this? Well, let's go ahead and say that I want to move from my current location to some new location based on the ball's velocity, its speed, in the X and the Y direction. So I need to actually take a step back and assume that there's going to be a velocity associated with this game. I could put it in a bunch of places, but I'm going to keep it simple. I'm going to go ahead and say that I have a velocity that, let me be consistent with what I have online, CG point. I'm going to just define an IVAR called velocity. Now, this isn't exactly a point, so I'm kind of abusing it here, but the point has an XY value, so I'm going to use this really as a vector. So the X is going to be how many miles per hour it's going in the X direction, negative or positive, and the Y coordinate won't be a point. It will be how fast it's going vertically, up or down in the Y direction. And it's not miles per hour, it's going to be pixels per second or points per second, or some multiplier thereof. So let's go ahead and actually set that. So among the things I'm going to do in my nib are set my velocity to do CG point make. And let's go ahead and say 10 points at a time and 10.0 at a time. The F's as a suffix for the floating point values here isn't strictly necessary, but I'll do it just because by default they'd be doubles. I want them to be floats just to be super anal here. But 10s would work by themselves as well. So now I have a default velocity, 10 pixels this way, 10 pixels this way per some unit of time. Thanks to my timer, I can implement this notion of per units of time. So down here, when I'm updating the center of the ball, I really want to say go to wherever you are, self.ball.center.x, CG float. Yep, it was a floating point value, generalized away as CG float. And what do I want to do? I want to go ahead and add whatever my current velocity is, its x component, which is 10 points per second, 10 miles per hour, whatever the units in question are. And I then want to do, actually that's fine. Whatever the x component is, I'm going to move 10 points. And then for the y coordinate, I want to go ahead and say wherever you are, let's get rid of this, self.ball.center.y, then go ahead and add in the velocity.y. So again, velocity is the speed at which we're moving in each of these directions. So I'm really just saying every time play gets called, just move 10 pixels this way, 10 pixels that way. And if we do this again and again and again and again, we're going to essentially have the equivalent of animation. Yeah?
Is the reason why you didn't make velocity do property synthesizing velocities because it's a struct?
Exactly. Yeah, so this is subtle, but you would trip over it if you made it a property. For now, it is very much deliberate that I made velocity a struct and not a property, because even though we have this thing called CG point, which is capitalized, feels like an object, it is in a sense, but it's not being stored by pointer. It's simply being stored by value. So if you did define velocity to be a property, and with that you'd get a synthesized getter, what you'd actually be getting every time you called the getter with the dot notation is a copy of that structure. So changing its x and y fields would have absolutely no effect. So this is why a lot of people kind of grimace that Apple chose the dot notation, among other reasons, for properties, because it actually is used also for structs. So when we're saying center.x and center.y, we're not invoking getters. We're not using synthesized properties. Those are old school C-style struct accesses. So very good point, and you would only trip over that if you actually tried a property first. You'd find that actually Xcode would notice that you're trying to illegally assign a value to it on the left-hand side. All right, so I think we're moving. It's going to kind of zoom right off the screen. But unless I've made an error here, let's go ahead and run this thing in the simulator. Nope, I made an error. All right, let's see what we're doing wrong here. What's that? Did I hook it up in the nib? That's a very good point. No. So when in doubt, see, I told too much of the story. Very good debugging technique. Always check your connections. In this case, I have no recollection, frankly, of wiring this, so I probably didn't. We have 3 outlets we need to connect. Yeah?
Is center a property that, or an attribute property in a generic sense that you defined, or is it a property of the view?
It is a property of the UI view class. Center is a property of the UI view class. If you change it, it makes it move, yes, because the view will be repositioned based on that center. All right, so let's do this quickly. Thank you for catching that. I'm going to drag with control held files owner down here, wire up the ball. So I was sending those messages, as we saw from nslog, but they were simply going to nil. So nothing was happening, but nothing was crashing either. All right, so now let's try the same thing. Watch closely, because the game's about to end. Woo! OK. So not the best game, but we're pretty good. We're pretty capable now of detecting when it's going to bounce off the edge. We can programmatically check what the dimensions are, because in fact, if I put even more effort into this, I could absolutely support the iPad and simply have a separate nib for it that actually has the right dimensions. But for now, I'm going to go ahead and keep it somewhat safe, and I'm just going to assume my 320 by 480. So let me go ahead here, and let me stop wasting time with the log there. We'll kill that. And let's go ahead and now do some detection. So if I actually want to now detect if I'm bouncing off of something, let's go ahead and say if self.ball.center.y is less than 0. So this implies that it's where? Above or below?
At the bottom. Oh, sorry, at the top.
OK, I heard a little bit of both. Only one of those answers. So it's above, right? So remember our coordinate system. The XY coordinate system starts at the top left-hand corner, which is 0, 0. So if the pixel location of the ball is less than 0, that means he's up there. And so we want to reverse his direction and flip his Y velocity around. Sorry?
Comparing the center, though, not the edge.
So that's true. I'm going to actually clean this up in a moment, because my ball is actually 10 pixels. So he's actually going to be kind of off-center. So we can fix that. But for now, we're just going to go ahead and assume that he's partly off the screen. And that's OK. There's a little bit of padding on the side. All right, so if it's less than 0, or if self, we can actually do this programmatically. Self.view.bounds.size.height, so I don't have to hard code my values in here, is less than self.ball.center.y. And this is where it's really sad. I mean, we're commingling properties and C structs here, but such is the syntax. So what am I asking here? So if the ball's center is less than 0 and thus above, or if the ball center is above the height of the thing and the height grows downward, that means it's now below the screen. Now we want to let it keep moving, but we want to change directions in the Y direction. We want to create the equivalent of a bounce or a reflection. So let's go ahead and do this. I want to now change my velocity to be the opposite. Well, this is actually pretty easy. I can just say, well, whatever the velocity is in the Y direction should simply become the opposite. Literally, I'm going to go ahead and negate it. So he's going to keep moving in the X direction, but whereas he was going 10 miles per hour this way, now he's going to go 10 miles per hour that way. And if you add those two vectors together, you're going to get a positive diagonal. So let's see what happens here. So let's do a comment, bounce off top and bottom walls, just to be clear. Let's see if we got that right. Cool. Uh-oh. All right. But this should be easy to fix too. So now we just have to do the side. It's not actually playing the game just yet, so we'll fix that. So bounce off left and right walls. So let's fix this. So if self.ball.center.x is less than 0, or self.view.bounds.size, sometimes you can be faster than autocomplete, width is less than self.ball.center.x. So it's really the same question we're asking. We want to go ahead and set the velocity of x equal to negative velocity. And now notice we're not moving the ball at this point. Sorry, thank you. Yeah, weird things happen if you flip your axes. Thank you. Got it. OK, so notice that we're not actually calling move again or changing the center. Why? The method is ending. Well, it's going to get called 0.05 seconds from now, so I'm just going to let that next iteration of the message take care of that. So let's see. It's getting kind of fun. All right. Now, this isn't Pong, right, because the paddles are kind of useless, but now you can maybe imagine how we now can leave in place the top and bottom mechanisms and just let it bounce off the top and bottom, but we clearly want it to stop bouncing off the right and the left, but instead require that the user actually touch it with the paddle, or the computer touch it with the paddle. I'm also a bit nitpicky here. I kind of don't like that it's kind of flowing half off the screen and that it's bouncing, as though there is some kind of buffer or padding there. So we can actually fix that. We know that the ball is 10 by 10. I could do this programmatically, but I'm going to go ahead and leverage that and actually say if it's less than 5, so if it gets close enough to be right there, I'm going to go ahead and yell at it there. Or if the height, -5, is actually in the way, and then I'm going to do the same thing here. And I'm choosing 5 because, again, the ball itself is 10 by 10, so half of it is 5. Now feels a little cleaner. And now it's kind of like that episode from The Office where you can wait until it gets just in the corner. Anyone? No? OK. All right. So we're all getting there. So now we actually can talk about UI views touching each other or somehow detecting the presence of another frame or bounds within their same context. So this thing that's moving around is still just a 10 by 10 UI image view moving. So we really need a way of asking the question, is he touching another such rectangle? Is there any overlap? And if there is an overlap, even if it's 1 pixel, we're going to use that as an excuse to reverse the x direction of the velocity so that it actually appears to bounce off the paddle. And then we can go back and instead of letting it bounce off the back wall, we'll simply detect if it goes off the back wall at all, well, bam, we're going to go ahead and give a point to the other guy. So let's go ahead and add the paddle support now. So I'm going to go ahead and do it for the right-hand guy. So this is going to be the actual user. So bounce off right paddle. So how are we going to do this? Well, we have this function accessible to us. If CG rect intersect rect. And now we need to specify 2 rectangles. So I have my own self's ball pointer and its frame. And recall that the frame represents the rectangle of it. And it just so happens to be, there's no offset there. So it's actually pretty equivalent to the bounds. Now I'm going to go ahead and say, is the frame touching self.paddleLeft.frame? So again, frame, just like center, is a property that's been associated with every UI view we've been using for weeks. We've just not really needed it just yet. So this core graphics function is just going to say, are these 2 rectangles somehow touching by at least a pixel in any direction? So that's pretty nice. So if that is indeed the case, I want to go ahead and say, well, let's go ahead and say, we can steal what we did before. Underscore velocity.x gets negative underscore velocity.x. But I want to do a little tweak here. If I go back to the simulator, let's get rid of this for just a moment. I want to be careful here because in Pong, really you only want that thing to bounce off of the insides of the paddles. So either over here or over here. I don't want to get into this weird situation where it's oscillating back and forth between the right-hand side and the left-hand side and one of the paddles. So I'm going to add a little check here. And rather than just bouncing off the paddle, like I said, I'm actually going to ask too, if the center of the ball, so if self.ball.center.x is less than self.paddleRight.center.x. So in other words, is the ball to the left of the center of the paddle, in other words, it's coming in from the right direction, then I want to go ahead and update the velocity. Otherwise, I don't want anything to happen. I want it ultimately to just go right off the right-hand side. So let's go ahead now and get... Oh, yeah, this is not good. OK. Do as I say, not as I do, clearly. OK. That looks better. All right. It's not perfectly correct. Let's fix my indentation at least. But let's see at least what happens now. It can bounce off the paddle, but it can also still bounce off the wall. So that's kind of interesting. And that's definitely a little buggy. What's actually going on there? It's kind of pretty. I wish it were deliberate. What might be going on?
Just define it as the spec.
This is my version of Pong. So that's kind of interesting. So what's going on here? It kind of feels like it, right? That the frame is a little bigger. So let's do a little sanity check here. Let me go back to my nib file. And I'm going to right-click on, or click on that. I'm going to go over here to my measurements. That's actually okay. So that's a little weird. Thinking back. I'm actually thinking on the fly because this actually happened to me for like an hour today. And in the end, I attributed it to a bug because recreating it actually fixed the problem. So let's do this. Let's take the cake out of the oven. Since I can say with fairly high certainty what we just did was correct and the nib is not actually... Actually, let me at least explain what's going on, lest this seem like complete black magic. Let me go ahead and open up Pong again. And I'm going to go ahead and do this, let's say, in the view controller. Every time it, let's say, bounces, so every time I seem to be touching the thing, let's do this. Let's log to NSLog. This is literally what I did earlier today. So width equals some floating point value. Height equals some floating point value. And what floating point values do I want? Well, let's go ahead and say NSFloat. Width gets self.paddle. Let's do it on the ball. Self.ball.frame. Self.ball.frame. What did we get at? Something's wrong here. What did I do before? Nope. It's not liking this for some reason. Oh, you know what? What's that?
I think it's like a rectangle. It has an origin property, a size property, and each of them is like one is a point and the other one is.
Okay. Let's see. Self.ball. No, what something?
Frame.origin.
No, it's still not liking this. I'm not saying.
It shouldn't matter anyway. You're taking the center. Yeah.
No, but what I want. What is wrong? All right, let's do this. I will figure this out when I don't have eyes staring at me. And let me do this. Let me go into this version here. Essentially, what was happening earlier was even though in the nib file we specified that the width of the ball was 10 by 10, and we did that with the little inspector, and then we did the same for 10 by 60 for each of the paddles, for some reason it seemed that the nib file was not actually properly storing those settings, such that it was an arbitrary 330, or in this case looks more like 1 or 200 by something. And I was not able to attribute this to anything other than Xcode weirdness because dismantling the nib and redoing it from scratch fixed that earlier. So I'll take another stab at that and see if I can recreate the same fix as before. So let me go ahead and propose that what I've done in advance, and I'm not going to unwire this list to break on us again, I've actually added two labels. The font is perhaps excessively large, but I wanted just some placeholders, score left and score right. Those are just two UI labels. I've given them two IB outlets because recall that the goal was not just to implement Pong, but was to also implement this scoring system, 0 points here, 1 point here, for instance. All right, so in my viewcontroller.h, in advance, I've done just a couple of things. I've added label left and label right. We already had paddle left, paddle right, and also the ball. And we'll see in this version that's already been pre-baked, I also have a Boolean field for paused because I realized that it's a little annoying if as soon as you get a point, the ball just keeps going and you kind of want to pause, get your wits together, and then start again. So there's going to be this flag that by default is true. The game is paused, and every time one side or the other makes a point, it's going to pause again and recenter the ball. And then I have score left and score right. These are just going to be unsigned integers whose values are going to end up in the label left and label right. So hopefully no new magic there, just simply some values I wanted to store. Velocity is still defined up here. So really then I've added some logic now here. And I did clean this up. Rather than doing some of this on the fly, I, for instance, defined a constant where velocity is 10.0 in floating point units. And then I still initialized that in my awake from nib. I synthesized all those same properties. And now let's just notice what else I did. It's not all that much to get to the end of Pong, to be honest. So awake from nib first initializes score left and score right to 0, because I just need them to be some known value. Then I initialize my velocity, this time using the constant. So this is one change versus the one I was doing on the fly there, just a little cleaner here. And now I scheduled the gameplay, just as I did before. So this is identical. So the only new thing here is now the ability to keep track of score. So let me go scroll down now to my, let's say, play method. And now I just have a couple new lines. If self.paused, return. So in other words, if I've said I'm paused, don't do all this messiness of checking and moving things. Just leave it alone. This line is identical. I'm going to go ahead and move the ball by velocity.x factor and .y factor. And now I'm going to detect goals. So this is new code, but it's conceptually identical to bouncing off the wall. Instead of bouncing off the wall, I just want to say, wait, go ahead and add a score to whoever just scored, and then call this other method called kickoff. And kickoff, I just realized by futzing around that I kind of need to factor this out. So kickoff means recenter the ball and pause the game. That's all. We'll see in just a moment. So self.scoreRight means give the guy on the right 1 point. And this should make sense, because if the ball center, its x coordinate, is less than 5, which hand does it mean it's on, left or right? All right, so it's left. It went into this goal over here, which means the guy on the right deserves the point for having scored on the left-hand player. Then we call self-kickoff. Else, if instead the ball is to the right of the screen, we kind of do the opposite. We increment the left guy's score and then call kickoff again. So this is the scoring mechanism. It only took a simple branch. Now I still have the identical code from before, bounce off the top and the bottom walls as before. Now it got a little interesting with the paddles. So I didn't implement the left paddle before, but it's pretty much a copy and paste of the right. This code we already wrote together. Bounce off of the right paddle. So if the ball intersects with the paddle right's rectangle, go ahead then and double check that it's not stuck between the edge and the paddle, although in theory that should not be a problem now that we eliminated the boundary constraints and just let the point get scored. But we reverse the x direction, or in this case, rather, we reverse the x direction as well based on whether or not it's hitting the left paddle or the right. In either case, you reverse the x direction irrespective of what side of the screen you're on. So that's our bouncing. So now let me scroll past that, and we'll come back to that. So let's just look at this kickoff method. So the kickoff method is actually pretty simple. One, when I start the game by kicking off or after every point, I just want to update the score labels so that I see if it's 0, 0, 1, 0, 2, 0, whatever. So this is old school tricks as before, using NSString and string with format. And I'm just passing in the score left and score right. All right, over here, notice I'm centering the ball. And I hard-coded this, but I could abstract this away. But for now, I just put a dead center in the iPhone screen, landscape orientation, and then I pause it by default. So this begs the question, how does the user unpause the game? Well, I decided the simplest and most intuitive would probably be to do what? You just touch the screen, right, and let things go. So how do we do this? Well, we saw in previous weeks how we can actually support gestures and swipes and pinches. Well, you can actually do a much simpler thing with touches. So there is a method that can get passed to a message that can get passed to any UI view, namely touches began. It passes you a set of touches, maybe 1 finger, 2 fingers, 3 fingers, whatever's been touched on the screen. You get any such touch objects, and then you also get the actual underlying event. So this is all it takes to actually unpause the game. If you detect any touch, I don't care if the user used 1, 2, 5 fingers or more, it's just going to turn off the pause, and therefore the game is going to begin, which means now the play method keeps getting called every 0.05 seconds, but this time it's not going to return immediately because paused is not in fact true anymore. Well, what about actually playing this game? Well, how do we actually have the how do we have the right-hand guy? Let's assume that the guy on the right will be the human, and we're going to have some artificial intelligence on the left-hand side playing the computer. How do we implement the human? Well, it's actually pretty easy too with one of these touch methods. So just as there's touches began, which is the very first time you touch the glass, touches moved keeps track of your dragging your finger in some coordinates on the screen. So how do we detect this? The syntax is essentially the same. We get a set of touches, 1 finger, 2 fingers, or whatnot, with the same event pointer. And I'm going to claim that now I'm going to follow the user's finger vertically. I'm not going to have him move the paddle all the way around the screen. Wherever he touches on the glass, I just want the paddle to move up and down similarly. So how do I do this? Well, here's how I get a touch. Frankly, I don't care how many fingers the guy is using to play the game. I'm just going to choose one of them randomly. So a not uncommon approach is just to say, give me any object from the set. Doesn't matter which one, because all I care about is the vertical axis. If he's got all 4 fingers there, any one of them will do. And it's relative positioning that we care about anyway. So go ahead and choose CG point. So CG point is just a struct. I'm calling it location. And I'm asking the particular touch I chose, what is your location in view? So with respect to the 320 by 480 screen here, what is your pixel coordinates, x comma y? Because now all I want to extract is the y component. So wherever the finger is, I want the paddle to line up. I don't care where x, y horizontally the finger is. So I'm going to do self.paddleRight's center is going to be the result of making a core graphics point at wherever it is, self.paddleRight.centerX, but location is going to change. So location is from the finger touch. This is identical to wherever he currently is. We're saying stay where you are x, but move to this y location. So the end result is that when I now move with my finger up and down, that paddle should actually follow me. And you'll see that I actually pre-baked a line to be sort of respectful of the tradition. But what about the AI? Before we actually play this thing, what would you do if you're the developer here who has to implement a computer player? What should the computer, the left-hand paddle, do? Yeah, so it should kind of follow the ball, right? The computer could potentially have a perfect advantage here. He could just frankly teleport to wherever the ball is about to be and grab the ball. But really, if we want to give the human a fighting chance, maybe we should at least have the paddle just at least track the ball. So as the ball is going up and up and up, just defensively, the left-hand player should move up and up and up and down, 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 down when the ball is actually going down. So how might we do that? Well, that was the code I breezed over before. I commented it as move opponent as ball approaches. So I'm proposing this. So if the velocity is currently, the velocity.x is negative, well, we'll see what that means in a moment. Let's focus just on the easy one. So move down. When should I move down? So if self.ball.center, so if the center of the ball vertically is lower than the self.paddleLeft.center. So if the ball is physically, here's the left paddle. If the ball is down here, what direction should I move the center of the paddle in? Down. And I just arbitrarily chose move it down 10.0 points. Now I could change this. I should probably make it a constant or some kind of parameter. But now if you start thinking, you could pretty easily turn this into a utility application with a slider or some other controls. So you could speed up the game, slow down the game, grow your slider, shrink your slider. And so we could do some interesting things. For now, it's just going to move down 10 points. Else, if the paddle is actually below the ball, I want to then move the paddle up 10 pixels. Now, this might not be enough if the paddle and the ball are this far apart. But again, this is happening every 0.05 seconds. So hopefully, if the ball is not going too fast, the paddle will actually catch up. So let's actually see this in the aggregate. Here is my simulator. I'm going to go ahead and click anywhere. And now notice, I'm the guy on the right. There we go. This is a lot of hard work, so I hope you're impressed. All right. The thing about Pong is it gets boring pretty fast. So let me throw the game. OK. Now let me try to throw it again. There we go. All right. So he got a point. The ball got recentered. And as for this line, we'll take a look at how we did this in a moment. But let me go ahead and click again. Whoops. Oh, 2 for him. Now, how could we make it even harder? Now, notice one optimization. I waved my hand at the if condition that said if the x direction is positive or is negative, respond. So notice that the computer only moves when the ball is coming at him. I decided it would be a little lame if he constantly tracked the ball. But you could imagine other heuristics whereby he moves only at the last second potentially. Or we can make him a little better. Rather than moving him 10, what if we move him at 20 paces? Let's see if we can see the difference. So rebuild, reload, replay. OK, he's pretty, yep. Well, now he's moving. We'd have to change the timer if we wanted to make that a little more elegant. But he's definitely taking more steps at once. So it doesn't look quite as pretty. but we could also change his dimensions and frankly make him 320 pixels tall, and that would make for a pretty lame game. So what's actually going on underneath the hood? Let's go back to the nib for just a moment and notice that I did one interesting thing here. I decided that to be true to the game of Pong, I wanted to have that midfield line that demarked left side versus right side. So I could do this in a number of ways, but I kind of decided that I really wanted to draw this thing. And in fact, in the final version of this, I really want to remove the lame ping approach I took with Photoshop. Photoshop really is not an integral part of this project, nor of core graphics itself. So notice one stepping stone to this is this. Rather than have a default UI view, so by default, when you create a view-based application, you get files owner, first responder, and then view. But I called this Pong view because I decided, you know what, I want to have a special UI view class that I myself am going to implement. And I'm actually going to implement this new method called drawRect for draw the rectangle. So the idea here is that when you usually use the view-based application template, you get for free a drawRect method that really doesn't do anything, because this is why your screens by default are always black or gray or white or something very ordinary. I want mine to be a rectangle, but with a dashed line down the middle, thereby representing the turf. So what did I do? Well, in my nib file, I simply made sure that on the left-hand side here, Pong view was selected. On the right-hand side view here, I went to my identity inspector. And recall we did this weeks ago with the controller. When we wanted a custom controller object, I just found Pong view in the menu and said, I don't want some lame UI view that I get by default. I want my view. And I myself am going to implement a method called drawRect. So here's my .h file. How did I get here? Well, we've been doing this again and again. I right-clicked. I went to New File. I then specified that I want a new not strings file. I want Cocoa Touch, Objective-C class, enter. And by default, recall this is always NSObject. Well, I changed it. I want a child of UI view because I want to implement the view myself. Then I went through the subsequent steps and I got two files for free, pongview.h, pongview.m. In the h file, I really didn't expend much effort. So that's all that there's there. And in the M file, I actually did the juicy core graphics part. And Tommy will end up continuing this conversation with even sexier things. But let's see what's going on. So at the top of this function, or this method drawRect, I'm calling the UI graphics get current context. So very verbosely named. You can think of this as saying, give me the canvas, the blank Photoshop-like canvas for this rectangle. So I can start drawing on it and coloring things. Drawing dashed lines is actually a little weird syntactically. You first literally declare an array with some number of pixel lengths as to how long do you want the pen on versus off versus on versus off. I just wanted it to alternate on, off, so I went 1, 1, but you can experiment with other values. Then I called this setLineDash function. I pass in the context because it's asking me, where do you want to draw this line? On what canvas? Well, the current context. Where do I want it to start? 0, 0. What dashes do I want to use there? And we pass in then a stroke color. So that specifies the dashing mechanism. Now I want a stroke color. Well, what color do I want to use? Well, if I scroll to the right, you can actually specify millions of different colors. But this was Pong. I could get away with one of the hard-coded special ones, a web-safe color in some sense. A UI color, white color, but this is a UIKit class, UI color. I want to get its CG color equivalent, core graphics, and now that will pass in a value that this core graphics function understands. So now I have prepared the context for dashed lines. I've prepared the context for white lines. Now I have to specify a width that I want. I decided arbitrarily that I'm going to draw with my marker in 5 pixel widths. I then specified go to the point 240, 0. So go over 240 and down 0. So that puts now I'll change the analogy. This is the guy who's painting the football field at the very top middle of the field. Now I want him to walk downward. So I add a line to that point and end up at 240, 320, which is all the way at the bottom. And again, I could abstract away, especially if I wanted to support like the iPad or a different device with different dimensions, but I kept it simple here. And then this last one is that it actually says, turn on the paint. I keep changing the tool I'm using, but actually draw what you just prepared to do. And so this drawRect function method will get called anytime this UI view is rendered. I'm not actually allocating any memory in any of this. This is all C functions from core graphics. I don't have to do anything special with dialog. In fact, I could rip that out and just use the super view, the superclasses implementation of it. But the end result, as we saw, is that you get a canvas that looks quite like this. And the projector doesn't quite do it justice, but this is indeed a dashed line going from top to bottom. So how can we now get rid of our pings? Well, let's just open a very simple example that hints at how to do this. We won't rip it out from the actual game. But in this paddle project, whose source code's online, I did something very simple. I started with a view-based project. And I created, again, a paddle, instead of a Pong view class, I created a paddle view class. This, too, its H file had nothing interesting, but its M file had this. The purpose of this class was to create a UI view that I could now use instead of UI image view, which again was kind of a lame approach. So in version 2 of Pong, what I'd want to do is borrow code like this, implement my own paddle view to replace UI image view, implement its own drawRect method, and it's actually pretty easy to draw a rectangle. I simply specify a CG rect, core graphics rectangle. It's going to start at pixel coordinates 0, 0 arbitrarily, be 10 pixels wide, 60 pixels tall. I'm going to set the current the state color to white, and then I'm going to call this special function UI rect fill that square. So now I have a special UI view object that I can then use. And so the last thing I would do, and did in very simple form in this program called Paddle, is this thing here. We did this ages ago with our no-nib example when we got tired of using Interface Builder. If I want to add a paddle to Pong or to this simpler project, I simply allocate a paddle view using alloc and init of the custom class I just made. Then we did this weeks ago, self.view, add a subview to specifically this paddle view. So take the small little rectangle you just made, add it as an overlay on top of the current view, and then actually release the pointer you had. So the end result here isn't quite as sexy as Pong, but it's been shipped away to just be the core graphic content, so that now in this, it's not even a game. I can move this up and down, but this is no longer that Photoshop ping. Now it's actually a graphic I myself made. And so now you can imagine having on the back of this application sliders or whatnot and grow that rectangle just by changing its height and width. You can move it around even. And indeed, the code I used to actually have it follow the cursor was just copied from Pong itself. So all of this code is available online. Tommy will dive into even more sophisticated techniques tonight. But especially if you want to do something interesting graphically or game-wise with your student choice project, realize that there's a lot of capabilities now within your reach. So we will see you next week for our final shorter lecture, and we will wrap up then.